Good morning, students. Welcome to the physics class. Chapter 1, Electrostatics. Firstly, we have to discuss this word. What is the electrostatic? Electrostatic word is the combination of two words, electro and static, where the electro means charge and the static means rest. So here we are discussing about charge at rest. The electric charge. Now, what is electric charge? Electric charge is the property of the charged particle due to which it exerts force on other particles. So, electric charge is the property of the charged particle due to which it exerts force on other particles. The charges are of two types. Charges are of two types: positive charge and negative charge. The similar charges, that is the like charges, repel each other, and unlike charges attract each other. Any particle have positive or negative charge. The number of positive and negative charge are equal, then the matter is called basically neutral. If the number of electron is more, then it is called a negative charge particle, and if the number of protons are more than the electrons, then it is called the positive charged particle. On the classification of the material, the materials are divided into three types: conductor, insulator, and semiconductors. Conductors are the materials which have free electrons. For example, metal, tap water, human body. They are the conductors. They are called conductor as they have the free electrons and they have the capacity or the capability to conduct electricity. And the second type of charges are insulators. Insulators are those materials which don't have any free charge particles or free electrons. They are called insulators. They don't conduct electricity, so they are called insulator. And the example of the insulator are glass, pure water, and plastic, or etc. This is the basically reason that's why we cover the electric wires with plastic or any other insulators. And the third type is dielectrics. Dielectrics, these are also insulators, but they have the strength that they can spread the charge over their whole body. Suppose we have this matter. If it is the insulator, then if we charge this end of the rod, then the charge is placed over this rod only here. And if it is a dielectric, then this charge will move to the whole body of the rod or any other material. This is the basic difference between the insulator and the dielectric. Dielectric are of two types: semiconductor and superconductors. Semiconductors are those whose properties are made between the conductors and the insulators. Basic example of semiconductor are silicon and germanium. They are mostly used materials. Next is the superconductor. Superconductor are the material which present no resistance to the movement of charge through it. They have basically zero resistance. That's why they are called superconductors. And after superconductors, there is the property of electrostatic induction. Basically, we use induction pressure cooker at home. What is the process or the word induction? Induction is the polarization of charge in a body or charging a body without any contact between the two bodies. Suppose this is a positive charged body, and when we bring a non-charged body near a positive charged body, then it acquires a negative charge. Hence, we can say that to produce charge on uncharged body by placing in contacted without any direct contact between the both. Say these bodies are placed near, not any direct contact in between them. Suppose this is the charged body and this is the temporary charge by induction. This is a neutral metal sphere. It is called a neutral because it has a positive and as well as a negative charge. So this is the temporary charge. When we bring a negative charge body near this body, then whole positive charge come near to this positive charge, and when we ground this negative charge, then a negative charge of that body comes to the ground and it occurs positive charge. This is the concept of electrostatic induction. In electrostatic induction, we can charge a body without any contact between the two bodies. Basic properties of electric charge. These are the three basic properties of electric charge: additivity of electric charge, quantization of charge, and the conservation of electric charge. Additivity of charge means we can add any two charges. Addition of positive and negative charge makes a zero. Suppose we have a minus 19 charge on one body and plus 19 on another body, then they both make a neutral. That is the zero charge. As a Q1 plus Q2. This is called the additivity property of the charge. And the second is the quantization of electric charge. Quantization means the principle of the quantization is electric charge is not a continuous quantity but is the integral multiple of a minimum charge. Hence, we can say that while transferring charge from one body to another body, we can transfer an integral multiple of E. That is, quantization is equals to plus minus NE. We can transfer the integral multiple of electrons from one body to another body, not on the points or in the fractional forms. The minimum charge is 1.6 into 10 to the minus 19 coulomb. One electron has charged this, that is minus 1.6 into 10 to the minus 19 coulomb. After that, we have the property that is the conservation of a charge. Conservation of charge means the charge on the body before the reaction or after the reaction remain conserved, and it doesn't change. Suppose this in this reaction 238 uranium gives us thorium 94 plus 4 helium. As the jet atomic number of radioactive element is 92, so it has 92 protons, and the thorium has 90, atomic number 90, it has 90 charge, while the helium has two alpha particles. Helium is the alpha particle, and alpha particle has 2 charges, means it has 2 unit. It has 2 units, so it also become 90 plus 2 92. The charge before the reaction and after the reaction remain same. Any other example of it is annihilation. Annihilation, bare production, they also have the same charge before and after the reaction. It is called conservation of charge. And after that, we have the Coulomb's law. Coulomb is the name of the scientist who gives the force between the two stationary charge particles, so it is called the Coulomb's law. It drives the force between the two charged particles. This is the first charge particle Q1, and Q2 is another charge particle Q1, and they both have r distance between them. They show repulsion, means one force in this direction and another force is in this direction. Then the force between these two charged particles is defined as F is equal to C Q1 Q2 over R square. Or simply we can say that the force of attraction or repulsion between two charged particles is directly proportional to the product of two charges and inversely proportional to the square of distance between them. So by joining these two equations, we can say that F is directly proportional to Q1 Q2 over R square, and the constant of proportionality is C or K, and the value of C is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, and value of 1 by 4 pi epsilon naught is 9 into 10 raised to power 9. And the SI unit of the charge is coulomb. Coulomb is that quantity of charge which passes across any section of conductor per second when current of 1 ampere flow through it. So 1 coulomb is equal to 1 ampere into 1 second. In CGS electrostatic system, the unit is stat coulomb, and in SI system is the coulomb, and in CGS it's a stat coulomb. 1 coulomb is equals to 3 into 10 raised to power 9 stat coulombs, or 1 by 10 amp coulomb. 1 EMU, that is the electromagnetic unit, is equals to 3 into 10 raised to power 10 ESU, electrostatic unit. Coulomb's law in vector form. In vector form, we can say that we have the force, that is the F21 force. F21 means force on a second particle due to the first particle is equal to 1 by 4 pi epsilon naught Q1 Q2 over R square into R12 cap. That is the distance of first particle to the second particle. Here we have the two charges Q1 and Q2, and the distance between, as we moving from Q1 to Q2, then the distance is R12, and we are saying Q2 to Q1, we are moving from Q2 to Q1, and the distance is R21 cap. F12 vector is equals to 1 by 4 pi epsilon naught Q1 Q2 over R square into R21 cap. Here, as in F21 it's R12 cap, and F12 it is R21 cap. As the R21 is equals to minus of R12, and F21 is equals to minus of F12, and the Coulomb's law in vector form is resemblance with Newton's third law, that is the action and reaction are equal and opposite in direction. And after that we have the superposition principle. In superposition principle, if we have so many charges, just like that Q1, Q2 and Q3, there are the three charges, and if we have more than 3 charges, any number of charges, then the force on that charges is defined as F1, first force on first particle. It is equals to the F11, that is the force on first particle due to first, force on first particle due to second, force on first due to third, and it's a force on first particle due to the nth particle, and this all the sum of all the forces is equals to one force, that is called the principle of superposition principle. And this is the main summary of your first chapter, that is electrostatic. Keep doing it at home. Stay inside and stay safe. Thank you.